Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video we are going to discuss 25 most important troubleshooting commands that can be used on WAN-Edge devices in Cisco SD-WAN fabric. These all are verification commands generally we are using to troubleshoot the issues in Cisco SD-WAN fabric. So if you are a network engineer or if you are planning to become a network engineer, make sure you will watch this video till the end. And guys, after completion of this video, don't forget to share your feedback. Please share your feedback in the comment section. And if you will learn something from this video, then please hit on like button. Now without wasting our time, let's begin. Guys, as you know, in the SD-WAN fabric, first of all the WAN-Edge devices are going to establish control connection. First, they will establish control connection with vBond, then with vSmart and vManage. And after the control connection, all the WAN-Edge devices will have TLOCs of other sites. Their on TLOCs as well as remote side TLOCs. So directly WAN-Edge devices are going to establish IPsec, and inside the IPsec tunnel WAN-Edge devices are going to form BFD session, right? So whatever connections we have, the control connection for the control plane or for the data plane, like if I will talk about the control plane, so between WAN-Edge devices and vSmart, right, we'll have control connection by using either TLS protocol or DTLS protocol, and inside that tunnel these devices are going to establish OMP pairing. So first of all, we should verify these control connection, the IPsec connection, the BFD session, and OMP pairing. Then we should verify the TLOCs, that all the WAN-Edge devices are receiving TLOCs of remote sites correctly or not. Okay, so see here I have access of a WAN-Edge device. I can access any WAN-Edge devices. I have multiple WAN-Edge devices. Let's say this branch 2 WAN-Edge 7.7.7.7. I am going to access this WAN-Edge device, and here I have access. Okay, so first command I am going to use is control connection, just to verify the control connection. Before that, definitely you can check the running configuration by running command so running config, right? This command is going to show you the entire running configuration of this device. Like in the running configuration, you can see this is my system configuration, and under system configuration we have multiple types of configuration like host name configuration, system IP configuration, site ID configuration, organization name, right? Then vBond IP address, time zone. So these are the part of configuration of system, right? So under running configuration we can verify the system configuration, we can verify the VPN configuration, we can check the users and username and password, we can check the OMP configuration. OMP is by default enabled, right? Even we don't need to enable it, but this system configuration we have to configure it. This is not by default configuration. After that OMP is there, then banner configuration is there. You can see I had configured one banner. Like before the logging, if someone will try to log in this device, they will get this message there: only PM networking employees are allowed to access this device. And after the login, MOTD banner is this one: welcome to SD-WAN fabric. Then we have VPN 0 configuration. Under VPN 0 you can see we have BGP configuration, BGPS number 2. This is the neighbor command, remote ES, address family, and then under VPN 0 we have one interface G0/0. On this interface, this is the IP address. Then I have configured this interface as tunnel interface. The encapsulation protocol is IPsec, color is biz internet, and restrict, right, means it will not try to establish tunnel with MPLS color. Then we have allowed some services here, like allow service all, allow service netconf, SSH, right, DNS. So you can see these services are enabled here. Then interface is no shut. Then I have one more interface in VPN 0. Why 2 interface? Because here you can see all WAN-Edge devices are connected with 2 transport, internet and MPLS. So 0/0 is connected with internet and 0/1 is connected with MPLS. So that's why here I have the another interface 0/1 which is connected with MPLS. Even you can check the description. Here you can see the description connected to internet, and this interface description is connected to MPLS. Then we have the IP address there, then again tunnel interface, then encapsulation protocol, color, allowed services, then port is finally no set, and then we have one default route in the VPN. Guys, why default route? Because default route is configured towards internet, and between MPLS and WAN-Edge devices I am running BGP protocol. Okay, so in VPN 0 I have two interfaces. One is connected with internet router, one is connected with MPLS router, and towards internet I have configured one default route, and between WAN-Edge devices and MPLS I have configured the BGP protocol. Then this is my default route, and after that you can see service VPN configuration, VPN 10 configuration. Here description is LAN interfaces, and for the LAN interfaces in LAN side I am running OSPF protocol. So router OSPF, I am originating one default route here. These are the timer, and then we are redistributing OMP protocol in OSPF. And then in VPN 10 I have one interface G0/2. Even you can see in the topology 0/2 is my LAN interface, right, which is a part of VPN 10. Then 0/2 interface IP configuration and description. Here you can see description is nothing but the connected to internal router. And then for the management, finally we have VPN 512, that is management VPN. So this is the running configuration of my vEdge. Okay, then what I told you, after verifying the running configuration, running configuration looks fine. Now we can verify the control connection. We can use command show control connection. This is the second command, show control connection. It will show me the all control connection on this particular device. So you can see this device have control connection with vSmart, vBond and vManage, right? After verifying the control connection, and this control connection can be DTLS or TLS. So here you can see the protocol is DTLS, right? So make sure if there is issue, if you are troubleshooting the SD-WAN fabric, you will verify this, that control connection is established or not. And you can see like with vSmart we have two control connection, because I have two transport, one over MPLS and one over internet, right? And you can see the state is up, then uptime is there, and many more informations are there, like peer public IP address, port number, peer private IP address. I am not using NAT, so that's why private and public both IP address are same. Okay, so control connection looks fine. Here you can see it's working fine. Then we can check the IPsec connection, like all the WAN-Edge devices are going to establish IPsec. So we can check, so IPsec inbound connection, I can say, right? It will give me the all IPsec connection. So here is the output, you can see. Fine. So here also we can verify that all devices are able to establish IPsec over MPLS and internet or not. If there is any issue, you can troubleshoot it, right? Then here we can use one more command. So IPsec, we can check security association SA. So IPsec inbound connection, and then for the particular system IP address also we can check. We can modify the output by using pipe section. Then here we can say outbound connection also, we can verify outbound connection also. Then here we can check, so IPsec, what I told you, you can check the local SA, security association, right? So here is the output, you can see. So this way we can verify the IPsec tunneling on WAN-Edge devices. After that, this is the control connection verification. After this we can check the OMP pairing, we can check the BFD session. So third command or fourth command can be so OMP pairs, right? So you can see here we have OMP pairing with vSmart, and we have only one OMP pairing. So it doesn't matter how many transportation you are using, you will have only one OMP pairing with vSmart. Okay, so this is the routing protocol through which WAN-Edge devices are going to exchange the route, right? So two WAN-Edge devices or two sites are going to exchange routes through vSmart. Means, for an example, branch 1 and branch 2. So branch 1 will advertise their prefixes to vSmart through OMP protocol, and vSmart have one another OMP peers with branch 2 device. So vSmart is going to advertise that to branch 2. So this way two sites will exchange prefixes with each other, right? So here we can check the OMP pairing. The OMP pairing is up or not. If there is any issue, we can troubleshoot it. Then we can check the BFD session. We can say so OMP, not OMP, so BFD session, right? So it will show me the all available BFD session. Here you can see between all the WAN-Edge devices we have BFD session. If there will be any issue, here we can find that and then we can fix it, right? We can troubleshoot it. So this is also very important command for troubleshooting issues in Cisco SD-WAN fabric. Many time I am using these commands in the production network in the real time. Okay, so this way we can check the BFD session. Then we can check the TLOCs. If the a device is not receiving, let's suppose, TLOC, right? Or you have verified the BFD session. In the BFD you are not able to see BFD session with a particular site, let's say, right? Let's say for an example with 9.9.9 over the biz internet, BFD session is not up. BFD session is not up. So how we can troubleshoot? We can check the TLOC. Am I receiving TLOC from 9.9.9 or not? So we can use command so OMP TLOCs. So this command will give me the TLOC of all WAN-Edge devices. So here you can see TLOC of 4.4.4, which is the WAN-Edge device of DC. Here in the DC we have one vEdge system IP 4.4.4.4. So you can see here I have TLOC of 4.4.4, and for which color? For the MPLS. And we'll have one more TLOC from 4.4.4, our internet not there. So I think we have only one TLOC in DC. Two interfaces are there, but I am not receiving TLOC of 4.4. Yes, here you can see we have only one BFD session with DC vEdge, right? So the reason is TLOC. Here we have only one TLOC of DC over MPLS. Done. And here you can see the output. In output there are detailed information like from which device controller this machine have received, this box have received this TLOC, right? Or the color is MPLS and encapsulation protocol is IPsec. So you can see receive from 2.2.2.2. 2.2.2 is nothing but my vSmart. So what it's saying, this box have received this TLOC from vSmart, right? And status is this one, CIR. If you don't know the meaning of CIR, just let me know in the comment section, right? It's chosen, installed, and like if you need a detailed video, then I can make detailed video on it. By the way, the C means chosen, I means installed, and R means resolved, right? So this TLOC is resolved, installed, and selected. After that there are some more information, like you can see the encapsulation not important. Here the public IP address. Here we can check the public port number, we can check the private IP address, we can check the private port number. In my scenario both are same because I am not using any NAT device. Then you can check the status, BFD status. BFD status is up. From here also we can check the BFD status. Then side ID, you can see side ID of like DC from like side ID of this WAN-Edge device 4.4.4. so side ID is 100. Then the preference, these are for the like path manipulation. In BGP you might have learned about the local preference, about the tag. So these are exactly same, about the weight, about version. So these are the information inside the TLOCs. For all the TLOCs, for all the WAN-Edge devices we have TLOC, and we have similar kind of information you can see. And this WAN-Edge device is receiving all the TLOC from 2.2.2 only, except 7.7.7. 7.7.7 is there on TLOC, right? So I am on 7.7.7, so that's why here you can see peer is received from 0.0.0.0, means it is self-advertised TLOC. Fine. So this is also very important command to verify the TLOC. Again, here I have some more commands, like we can say so OMP, and then we can say I think services. Here is the output. So this way also we can verify the services. We can use summary command. Summary command also sometime I am using in the industry. Here you can see the summary information of OMP. Then you can check the path, TLOC path. So OMP TLOC paths. So this way you can see we are able to see all the path for the OMP TLOCs, right? So these are the commands related to TLOCs. Then guys, next command can be route checking, route like OMP route. So we can use command so OMP route. So how many route I am learning from the OMP protocol through the vSmart. Okay, so this command is going to show me the routing table of OMP protocol. Here you can see all are the routes, like 0.0.0.0 means self-advertised prefix, and here you can see this is self-advertised prefix, and this one is OMP route entry for VPN 10, right? Received from 2.2.2.2, and here are the informations, like the status is again same CIR, and the path ID is there, originator is there, who is originating, and originator over here you can see for this one, like who is originator 4.4.4.4. 4.4.4 is originating one default route. Actually this is not self-advertised, this is default route. Sorry guys, this is not self-advertised, this is default route receiving from vSmart. You can see peer received from this peer 2.2.2. so DC WAN-Edge is advertising one default route. Okay, so this is a default route, and again a status for this default route is chosen, installed and resolved. Then originator, who is originating this default route, we can check that. Type we can check the TLOC. As you know, TLOC is combination of three things: system IP, color and encapsulation. So system IP 4.4.4, color MPLS, and encapsulation IPsec. This is the TLOC. Okay, then you can check the side ID over here. Then you can check the next routes, the OMP routes, like this one, from where I am receiving this one, from this peer, from the vSmart. And who is originator? 5.5.5. 5.5.5 is branch 1, right? So branch 1 WAN is advertising this network through OMP protocol. So we can verify, like in the output of so OMP route, we can verify that which router is originating this route, from where I am receiving it, from the vSmart, right? So detailed informations are there. Then guys, here we can even filter the output. You can see all the routes are available. Here we can say tab. So this way also we can check the OMP routing table. You can see this is my OMP routing table, right? So here also we have same default route in VPN 10, right, from 2.2.2, and here is the path ID. Label is like tag only, the status, attribute type, TLOC IP address, color and encapsulation. So for all the OMP routes we have these information, detailed information, right? So this is how we can check the OMP routes on the WAN-Edge devices. So if there is issue, definitely in the traditional routing and switching also, what we are doing first, we are verifying the routing table of router, right, that route is available or not. After that we are checking ARP table, means my router is able to resolve MAC address or not. Here also you can check the ARP table by running command so ARP, right? So see, this is the ARP table of this WAN-Edge device. On this interface, this is the IP and this is the MAC address. A static method is static, right? And so that's why there is no any timer, and this is the uptime. For this dynamic MAC address, you can see on 0/0 interface, this is the IP 4.2 101.1.4.2. this is the MAC address, and method is dynamic, so that's why timer is running there. You know the ARP timeout. Okay, so we can verify the routing table, we can check the ARP table. Then guys, we can verify the routing protocols, like we can check the BGP neighbor. So BGP neighbor, right? So here you can see we have one BGP neighbor in VPN 0, right? As I am running BGP protocol between WAN-Edge devices and MPLS in VPN 0. So here you can see in VPN 0 I have one BGP neighbor, and the remote ES is neighbor ES number is 200, right? And the message received and message sent, 69 message received and 62 message sent to this particular neighbor, right? Then uptime is there, state is there, state is established. Then last uptime is this one, address family 0, right? So these are the detailed information about the neighbor. In the BGP we can check more information, like we can run summary command also. So BGP summary, right? Here you can see this is the neighbor, this is the remote ES, means the ES number of neighbor, message received, message sent, uptime, right? And the state is established. Then we can check the BGP route also. So BGP routes, right? So received route from the BGP protocol. And again, if you want to filter the output, you can run tab command here. This way you can check the BGP route, right? So in the same way we can check the OMP route, we can check the BGP route, we can check the OSPF route for the any routing protocol, and we can check the entire routing table. If you want to check the entire routing table, simply you can run IP route command, similar like routers, right? So this is the entire routing table of my router. Okay, so we have seen the BGP verification command also, like how to verify the BGP neighbor, how to verify BGP routes, right? How to filter the output. Then next thing is, like sometime we need to verify the certificate also on the WAN-Edge devices, so we can use command so certificate to check certificate, so certificate, and then we can say installed, right? So you can see the installed certificate on this WAN-Edge device. Okay, then we can verify the clock and those things also, like we can say so clock, right? So you can see the clock on this particular device. We can check the NTP server also, we can check the DHCP, like if DHCP is enabled, here we can run command so DHCP server, right? It will show you the DHCP configuration, but DHCP is not enabled right now because I am not using this device as a DHCP server. I have separate DHCP server in my network, but you can check it. Then we can check the history, whatever commands we have applied here on this device, we can check that by running command show history. These are similar like routers, you can see all the show commands I'm able to see here, right? So these are guys the troubleshooting command. Then we can check the interfaces of WAN-Edge device by running command so interface, right? So you can see all the interface in which VPN, 0/0 is in VPN 0, then IP address, right? Then status, administrative mode, and operational mode. We can check the encapsulation here, null. We can check the port type, which is the transport. We can check MTU, we can check speed, duplex, uptime, many more informations are there for all the interfaces. Again, if you want to filter the output, you can filter it. We can say so interface and then GE 0/0, so it will show you only this interface, this particular interface. And then so interface, and then you can see detail command is there. We can check the detail information of this interface, detail, right? And many more options are there, like we can check the description, we can check the error, right? We can see, we can check these all detail information of a particular interface. Then for FIB table, you can check the route. I already shown you how to check the entire routing table. You can check FIB table by running command show FIB forwarding information base. You can see the FIB table of my WAN-Edge device. Then show IP route, and we can check the NAT, show IP NAT. So you can see, as I am not using any NAT device here, NAT, and then so NAT should be there. So NAT, syntax error, so NAT, and then interface, right? So here you can see there is no any entry font for the NAT, right? So this way we can check the NAT also. Now like this you can check, you can verify the other routing protocol also, like let's say OSPF. I want to find the OSPF neighbor, because in the LAN side I'm running OSPF between my WAN-Edge device and internal router. OSPF routing protocol is running. So how to verify that? We can run again command show OSPF neighbor here. So OSPF neighbor, right? So you can see who is neighbor, OSPF neighbor, right? On which interface, what is the IP address of neighbor, in which VPN, right? The router ID, state is full, priority we can check, date interval we can check, right? So this way we can verify the OSPF neighbor. We can verify the OSPF database also by running command show OSPF database. On router you are running show IP OSPF database, here command is so OSPF database directly, right? So this is the database. We can check the summary information. We can say so OSPF database and then summary, database and summary. So you can see the summary of OSPF database, like in VPN, how many LSAs are there, router LSA 2, network LSA 1, so total number of LSA is 3, right? Then we can check interfaces, OSPF enable interface, so OSPF interface, right? It will show me all OSPF enable interfaces over here. Then we can check the process of OSPF, so OSPF process. So you can see the OSPF process output process ID 7.7.7.7, which is my system IP. Then we can check OSPF route, so OSPF route, right? So you can see the OSPF route, OSPF routing table, right? So this is a one network, in which VPN, again in VPN 10, area ID 0, cost is this one, right? Next hop is 0.0.0, it is self advertised prefix, right? So this way we can check. Here you can see for this prefix, next hop is network type, then next hop this one, right? So it is receiving from any another neighbor. And we can filter the route also by using tab keyword, tab. So this way also you can check the OSPF route. So you can see this router 7.7.7 is receiving these all prefixes from their neighbor, and I am on this router, on this WAN-Edge 7.7.7, and you can see on the router, internal router, we have these all LAN, right? So router is advertising these LAN through OSPF protocol to WAN-Edge device. So these all prefixes are there in the routing table, and this is the prefix which is subnet running between router and WAN-Edge device. Okay, so this way we can check OSPF routing table, OSPF route, OSPF neighborship, database, interface, process, route, everything we can verify. After that there are some commands for the security verification, like show security information. You can use this command to check security algorithms, like authentication type is, you can see this one, right? Because SD-WAN is a complete secure fabric, it's a fully secure fabric. Then we can check software here, right? So software, right? So you can see the software. Then we can use command so transport to check the transport. So transport, here you can see the transport option, like this one, system and here in real time you will have bit different output, right? Then we can verify the tunnel. We can use command show tunnel. So tunnel is syntax error, so tunnel, and then we can say statistics, right? So here you can see the tunnel information, GIE tunnel and IPsec tunnel, both types of tunnel, right? So I am using encapsulation protocol IPsec, I am not using GRE. So tunnel with 10.1.4.1 and 10.1.2.1 source port, destination port, system IP 5.5.5, means it is talking about the tunnel between 7.7.7, means branch 2 and branch 1 vEdge1 branch 1 vEdge1 and branch 2 vEdge, means 5.5.5 and 7.7.7 for this tunnel, right? Then color is there, local color and remote color. So as I have configured restricted in the color, right? So internet or MPLS can only establish tunneling with same color. Internet, a busy internet color cannot establish tunneling with MPLS. So here the local color and remote color is there. Sometimes it's very important to troubleshoot in the troubleshooting. Then tunnel MTU is there, right? TX, RX, these informations are there. Then next tunnel. So like this we have information of all the available tunnel here on this particular WAN-Edge device. Then you can check the uptime, like until when this device is up, you can use command show uptime. Here you can see the output. Then you can use user here. So user, this is also important. Sometimes we need to find the user, right? So there is only one user with name, you can see admin, right? And have CLI access from this particular IP address and on the console port. Got it? Then you can verify the version. So version command you can use here, and one more command I can discuss is, let's say VRRP. I want to check the VRRP configuration for redundancy. As you know, VRRP is an LAN redundancy protocol, FHRP, first hop redundancy protocol. So we can use show VRRP command. As I am not using VRRP, but in the real time when you will be using it, you will get the output. So guys, these are the commonly used troubleshooting commands in the Cisco SD-WAN fabric. Okay, and hope this video was helpful for you. If yes, if you have learned something from this video, please hit on like button, guys. If you have any query, question, concern, please let me know in the comment section. If you need any video on any other topic, please let me know in the comment section. That's all for today. If you are new on the channel, please subscribe this channel. And if you want to appreciate, right, for this particular video, if these types of videos are helpful for you, please share your feedback in the comment section, right? Just type yes. You can type yes in the comment section. Even if you don't want to share the feedback, just type yes. Yes means positive feedback. I will get to know that these videos are helpful for you. It will motivate me to make more and more videos like this. Okay guys, thank you so much for watching. I will meet you soon in the next video. Till then, stay safe. Bye bye. That's all for today.